Welcome viewers, this is stage 7 out of 7, which is a final stage of 220 kV double circuit transmission line tower structural loadings as per IS 802. In this we are going to discuss about the load trees and the load values which we had calculated from earlier videos. So before going to watch this video, you can watch our videos start from 1 to 6. In the first stage, we had to discuss about the electromechanical input required for the transmission line tower design. In the second stage, it is a reliability and wind load calculation. In the third, it is a classification of various load in terms of reliability, safety and security. In the fourth one, we discuss about the temperature and snow along with the sag trend calculations. In the fifth, we had to discuss about the reliability load combinations. In the sixth, we discuss about the security and safety load combinations. Now this is a seventh one, this is a final stage. We are going to apply all the calculated values so far from stage 1 to 6 of this video and compiling that into a load tree format so that it is easy for us to apply on the structural models which we got developed in robot structural models. So let me see in detail. So you can see an Excel sheet which is having the load trees. There are various load trees under each circumstances of load cases. So before going to look in detail about this load trees, let me look into that summary of load combinations. So these load trees are formed based upon these three major categories. The first categories of load combinations is reliability, second one is security, and the third one is safety. So we had already calculated this load values in our previous sessions. So under reliability we are having without deviation, with deviation. Under security we are also having without deviation and with deviation. And also for safety combination also we are having without deviation and with deviation. So here when you look into that summary of load combinations, under these three type there are again subdivisions based upon the normal conditions and the broken wire condition. Even in the normal wire condition and in the broken wire conditions there are two. One is without deviation, another one is with deviation. So these are the major categories and subcategories which we need to classify these load combinations. So if you come into the reliability load combinations, so there are only two load combinations, that too only under normal conditions. There is no load combinations for broken wire condition in case of reliability load combinations. So here one number of load tree is required for without deviation, another one is for with deviation. So these are all about the reliability load combination load trees. So total we are having two number of load trees for reliability. So that load cases we can name it as 11 and 12. Next one is security load combinations. In that for a normal condition there is no load trees, but for the broken wire condition there is 12 numbers in without deviation and 12 number is in with deviation. So totally it is 24 number of load trees we need to form. The load cases can be start from 21 to 44. So totally it is 24 number of load cases and load trees for security load combinations. And the third and final one is safety load combinations. In that we are having both the normal and broken wire condition. Under normal we are having one for without deviation and another one is for with deviation. So there are two load trees under normal conditions. And for broken wire condition, 12 number of load trees or load case we need to consider under without deviation, and for with deviation another 12 number of load trees or load cases to be considered. So in total for under safety load combinations we are having 26 number of load cases. that all the 26 number of load cases will start from 51 to and end at 76. So in summing of all the three categories under reliability and security and safety load combinations, we are having 52 number of load cases. All these load cases we had arrived without considering the factor of safety. So this factor of safety we can consider during the design or applying this load into that model, structural model which are developed in any of the structural softwares. So how we need to apply these safety factors is, so here in the IS 802 part 1 and section 2, it is given under class 17. So depends upon the quality of steel, we need to assume there are two factors, 1.02 and 1.05. Factors we need to consider is 1.02 into 1.05. So it is 1.07. So this 1.07 value we need to multiply it with all the loads which we are having as a load tree. Once after applying this load into that structural model which are developed in structural software, so sometimes this even instead of 1.07 based upon the customer or consultant requirement, we need to add even more the value in factor of safety like 1.25. So it's depend upon the project and other cases. So let me discuss in detail about the load trees. So first case is load number 11, normal condition transverse wind. In this under reliability loads, we are calculating, we are applying this load values in the load tree for without deviation. So all the left hand side load trees are for without deviation, conductor without deviation, and all the right hand side load trees are for conductor with deviations. So likewise we need to consider. So in some of the cases, if the conductor deviation is nearly 5 degree or which is having very nearer to that 0 degree or not, without deviation, we can calculate the both with the deviation and without deviation, and we can also consider whichever is maximum. Say for example, in this with deviation, the transverse load is 1071 for earth wire, but in this case without deviation it is 814. So we can consider maximum value in case if we want to reduce the load numbers, load cases numbers. So that is it's depend upon the design engineer who is performing this. But now here we are considering in detail about both with deviation and without deviation, because this calculation is to be adaptable for all the cases, even with the deviation or without the deviation, even if the deviation is more than 5 degree, or it is also applicable for suspension tower, tension tower and the dead end tower. So for that reason only it is this load cases are calculated separately for without deviation and with the deviation, even though the deviation is minor, say for example 5 degree. So let's we look into that. So this all the Fi are indicated the load in a transverse. Transverse means it is perpendicular direction to the conductor or earth wire span. So longitudinal means it is a parallel direction to the conductor or earth wire span. So you fix in your mind. So longitudinal means it is a parallel to the conductor or earth wire span. Transverse means it is perpendicular to conductor or earth wire span. So this is a direction of things we need to consider. So all the longitudinal forces we used to mention as Fx, and all the transverse load horizontal we used to mention as Fy, and all the vertical downward loads we used to consider that as F of Z. So this one. So this is a major component we need to consider in load tree. So for transverse load under reliability without deviation, so we need to take the value which we had calculated earlier. So this is for transverse direction Fy for reliability case without deviation. So we already calculated the here for the suspension tower there is also transverse load due to wind on conductor, wind on insulators. So as this is a suspension tower, the wind on tension insulator is not applicable. So this suspension insulator, wind and the earth wire, for earth wire we should not consider the insulator also. So 814 kg of transverse load to be applied on the nodal point of earth wire connection. So similar for this is a two circuit having a two earth wire fixing on the top of the tower. So this also the same value 814. When looking into the longitudinal force, that is a force parallel to the conductor span in the reliability level, you can see here the value is 0 for earth wire. Yeah, earth wire it is 0. So the same value is considered here. And also for vertical loads, you can see these are the vertical load. 128 kg is the weight of earth wire which we had calculated already. So that is, these are the force is applicable for these cases. So similarly, like for without deviation, we are having for earth wire it is 814 kg in transverse load direction plus this 257 due to the deviation, 5-degree deviation, there are some force. So this force, two force we need to submit and we can mention here as Fy. So for f of x, the same transverse force. So for earth wire longitudinal force it is 0 as we had calculated through this classes. So again for weight vertical load it is the same for both with deviation and without deviation. So these are all about the earth wire loadings. And next coming to the conductor, so for f of y, so for conductor you can also find here for f of y for conductor we need to add it this transverse load due to the conductor deviation and plus the wind on conductor plus the insulator wind on insulators. So adding this we are having 2243 kg. So this is what reflected here. And for again for longitudinal force it is 0. In reliability level we no need to consider this longitudinal force, even though there is a unequal span of conductor we no need to consider, because this unequal impact of longitudinal force due to this unequal span we are going to consider in security and safety load cases. So we can ignore this longitudinal force in all the reliability cases. So this is what described in IS 802 part 1 section 1 also. You can also refer that. So always this longitudinal force becomes 0 in a reliability load cases. So this is a wind load we need to apply. This wind load we already calculated here. Wind on structure 521 kg per meter square. So this 881 is a vertical load at the conductor point. So here we need to consider the weight of conductor adding to that tension insulator, suspension insulator. So it is coming 881. So again here we should not add this tension insulator in case of suspension tower. It's a small mistake. So 881 kg. So this is what all the forces we need to apply in every conductor fixing point. So they remain all the values. So these these three directional value we need to apply in all the conductor fixing point on both the circuit, left and right side. So this is what all about the reliability load cases. So next, so in the right hand side it is a deviation. So this 2827 is nothing but adding of this transverse load. So this one plus this one wind on conductor plus wind on suspension insulator. So it is coming 2827. So this is what here. So this vertical and longitudinal force are remain same as per this without a deviation. So next we are going to look into that security load cases. So in this, as we seen in that summary, for security load cases we need to consider only the broken wire condition, that too with and without deviation. So there are 12 cases. So let me see quickly. So for security load cases, first one thing is we are assuming that ground wire, both the side ground wire is broken. So in this case, for broken wire condition, we need to consider only the longitudinal force. Say for example, in the security load combinations for earth wire, you can see here for broken wire condition, we need to consider for suspension tower it is mentioned we need to consider 100% of earth wire, and mechanical tension we need to consider 50% of conductors. So this is what defined in IS 802. So here we are considering in a broken wire condition 481. So remaining for all the other conductor longitudinal forces we need to consider only 0. So those are not broken. So now coming to that vertical loads F of Z. So vertical load anyway it is common, same which we had calculated already, earth wire. So for earth wire, for broken wire condition we need to consider only the 60% of earth wire span. So it is 77 kg. So here we are considering 77 kg. So this transverse load for without deviation cases it is 0 due to earth wire deviation or conductor deviation, but for suspension tower even we should not consider any wind load as described in the class 12.1.2 of IS 802 part 1 section 1. So here you can see that the suspension no wind load should be considered. So for all except for tension tower and dead end tower we need to consider wind load. So in this case suppose if we are considering the line tower, say for example if I am changing this input to as a tension tower, small tension tower, and if you look into that tree you can find here some transverse loads on conductor, because in this class it is mentioned for tension tower we need to consider wind load on structure, also the mechanical tension we need to consider. So for transverse force we need to consider this 0 anyhow without deviation it is 0, but wind load we need to consider for broken wire condition anyhow we just assumed that the ground wire is broken, so we need to consider the intact wire wind. So it is 2015 with tension and suspend insulator wind loads. So adding that, it is 2399. One more load is missing, I think. Yeah, 2399 with the deviation. Sorry, without the deviation. For with the deviation, again we need to add conductor tension, mechanical tension with the deviation, and wind on conductor plus wind on tension insulator and wind on suspension insulator, summing that 2983. So we are considering here 2983. So this is applicable for dead end tower also. And vertical load remains same for both the cases, 871 kg, even it is with deviation or without deviation, we need to consider the same thing. But it's depend upon the broken wire condition and the normal condition, we need to think it of. If only the earth wire is broken, so then for that intact wire, we need to consider only the normal condition weight, vertical loads for conductor, insulator. So weight of insulator and weight of conductor we need to consider for normal condition. For if the earth wire, only the earth wire is broken, so that value, the summation is 871. The same 871 we are having here. So similarly, for line tower we need to consider wind in case of security loads, so which is described in this load case, that too in transverse conditions. So wind load is considered in the load cases for security under transverse loads for tension towers. So this 521 kg per meter square is not applicable in case of suspension tower, which is described in the class 12.1.2. So no wind loads to be considered. So you can see here, if I am just changing these to suspension tower and looking into that load trees, so not applicable. So this is what. Then next one is, we are just copy paste this load tree, and the load cases we are changing to 23 and 22. In this case, one side of earth wire is broken. So it means the weight F of Z, the conductor forces remain same, which we had calculated above. Only the earth wire fixing point. So here also the earth wire forces remain same in the left hand side of the fixing point, earth wire fixing point, but in the right hand side, because we are stating that one side of the ground wire is broken. So here what we need to consider is the full weight. So in this case, the transverse load we need to consider for full wind in case of a tension tower and a dead end tower. But for suspension tower, anyway, there is no forces, wind forces to be considered, it is 0. But this weight, we need to consider the full weight. So this earth wire weight, we need to consider this one, 128 kg. So this is what considered in the other side where there is no broken ground wire. So 128 kg. Other than that, there is no change compared to load case 21 and 20. So next one is, we are moving to 25 and 26. In that, what we are stating that is top conductor is broken in both the side. So in this case, again, this ground wire, earth wire fixing point is having the force similar like in the right hand side, say 0, 0, 128 and 42, 0, 128. So you can see here 42, 128 FZ and 128 FZ 0, 0, 0. So the conductor value also remains same. but only thing here, the conductor is broken at top fixing point. So in this top cross arm conductor fixing point, it is broken. So here we need to consider the longitudinal force which are calculated here. So as it is a suspension tower, so 1118 kg to be considered as this force. And also the weight of the conductor also we need to consider only the broken wire condition. It means reduced span. So here in the weight we had calculated here at 60% of broken wire condition as per the class 12.2.2 of IS 802.1. So adding this 60% of the broken wire condition with the insulators, of course here this tension insulator we should not add in case of suspension tower. So it is 685 kg in the sum. So that is what we are adding here. 685 kg is a weight of conductor suspension insulator. So in case of, let me check what is about the tension tower. So for tension tower, so here you can see that 6725 kg and also Fy is 1592 kg. So why this big change? You can see here in longitudinal for broken wire condition we need to consider 6725 kg, so which is stated in class 12.3.2. so that is why these huge forces are coming in broken wire condition. Mainly that design of tension tower is major things which used to have heavy forces in case of broken wire condition. So that transverse load, even transverse load also applicable, because in suspension tower there is no wind load to be considered as per IS 802. So here you can see in the transverse slide, no winds on tower or conductor or ground wire or even insulator string should be considered. But in case of tension and detent tower, we need to consider wind load. So that is the main reason we are getting this Fy value 1592, which are more higher. So next, if you come to that next load cases, say for example 27 and 28, in that we are defining that top conductor is broken in only one side, that is in left side it is broken, so right side it is fixed. So anyway, right side if it is fixed means both the spans are there, so there won't be any longitudinal force. Even it is a force also is there, it is a minor comparatively. So if it is broken, it is a huge impact. So here again this broken wire forces which we had calculated in our previous video. So the same value, only thing we are changing with this in the right hand side values with the bottom value which are normal loads. So only that alone we are changing. So this bottom conductor fixing point we are just copy paste here, because as it is we are defining here as a one side is broken, one side top guard is broken. So in the next cases 29 and 30 we are defining that is a mid, both circuit are broken. So the same 1592 kg which is we done in the top, the same value we are moving here in the to the middle. So middle we are having two, other values are for remain intact wire. So similar like one side of a mid conductor is broken, so we are applying that only one side in the mid cross arm, the broken wire condition, and the remaining things are same. So here this 2399 is a full span wind forces. So for example if you see here This is normal and intact wire plus wind on tension and suspension insulator is coming 2399 kg. So this is a full normal conductor. Also that weight we are considering conductor weight 100% plus tension and suspension insulator. So it is 871 kg. So this 871 kg we are considering for all the intact wires except for the broken wire condition. So broken wire condition we already seen what the value to be come. So up to 32, these are the phenomena. And the next one is 33 and 33 load cases. We are just moving this mid broken conductor to the bottom broken conductor. So here you can see for both the side it is broken means, so these are the load tree. So only changes is this, we are moving down a little bit here, and here remain intact wires in the mid span compared to the previous load cases. Like here we are doing as a mid arm which is having broken wire condition, and similar like here it is a one side bottom conductor broken. So next case is a broken bottom plus mid conductor. So here you can see both the mid and broken wire condition we are applying on both the mid and bottom, that too in one side, left hand side only we are applying. So this is a more critical. If we are applying for both the side, in this case it is not much critical because we already done that in our previous load cases. Here you can see the both the things we had applied that. So the critical cases we are doing now. Now next one is bottom, we had seen that. Then this one is bottom and top. So you can see here only in the bottom and top of conductor fixing point we are doing as a broken wire condition. Remaining things are intact forces we are considering. So next one is middle plus top. So these are that only on the middle and top we are applying this. So this is load case 41 and 42, and this is a final one in security load cases. So in 43 and 44 what we are doing is all the conductors, even bottom, middle and top, all are broken in one side, that is a left side. What is the impact? We are going to check in the design analysis. So here we are applying all the broken wire forces in the left hand side, and in the right hand side we are applying the intact forces. So with this, that security load combination is get completed. Next one we will look onto that safety load cases. So in that security load cases we need to consider both the normal condition and the broken wire condition. In the normal conditions we are having two, one is without deviation, another one is with deviation. So in that with deviation, if you are talking about, this is Fy, which is a transverse load. So for transverse load what we had considered is earth wire tension for both broken wire and normal tension. We need to, normal condition we need to consider as mentioned in class 12.1.3. Yes, we should not consider any wind load, any of type of tower, even it is a dead end or tension tower or suspension tower, no wind load to be considered under safety condition, because it is a construction and maintenance type of loads. In that, wind, considering a wind load is not reasonable. So here as there is no deviation, 0 degree we have considered in this case, in this tab, no deviation, then the transverse load for all the forces, all the, even it is a conductor or earth wire, it is 0. So in with deviation cases, so we consider already 5 degree of conductor deviation in our previous calculation itself. And also for suspension tower, if you look into that normal conditions as per this table which is stated in here as per class 12.3.3. For suspension tower there is no loads in normal conditions. Only in broken wire condition we need to consider this value 10 kN for conductor and 5 kN for earth wire. These are described in class 12.3.3 of IS 802 part 1 section 1. So here if you are look into this tree, you can see here for all the longitudinal forces are 0 in both with deviation and without deviation. Coming to that transverse load, so transverse load anyway we need to consider as per this. See here that wind load we need to consider here. Sorry, no need to consider the wind load in case of safety. But here again there is no transverse load. It is 0 for earth wire and conductor in case of deviation, but in case of without deviation. But in case of deviation there are some transverse load in conductor and earth wire. So this 195 kg we are adding here in the right hand side tree, and also for earth wire it is 42 kg which we are adding here as per this calculation and also as per this description given. So next one is that vertical load 257 for earth wire we are taking by adding this vertical load of earth wire under normal condition. So it is 257 kgs. So the same value we are consider for this earth wire fixing point for both with deviation and without deviation. But in case of conductor vertical loads, this 2272 kg which is coming out from here, it is which is a summation of this safety loads under vertical cases are given as per this class 12.2.2 and 12.2.2.3 of IS 802 part 1 section 1. So we had already calculated and discussed in detail about our previous video, that is in section in stage 6 of 7. So this is how we had calculated, and summation of all this insulator and conductor and weight of man with the kit and load at the tip of cross arm. So summation of all this we are applying in all the conductor fixing point, that is in middle, top and bottom conductor fixing point. So all the forces remain same for conductor fixing point and respectively that earth wire fixing point also. So this is what these two cases are for normal condition. Next we can move on that stringing. So here again similar like earth wire, similar like security load conditions, there we are considering is a broken wire condition, here we are considering is a stringing wire condition. So here the ground wire is stringing. During that all the forces where the stringing we are considering, only that alone will have the longitudinal forces. Remaining like a conductor fixing point all are should be 0 in f of x. So that is what we had done here. And in the stringing wire or broken wire we need to consider the weight vertical load only for broken wire cases. So like here you can see only the earth wire at broken wire span we need to consider, that is 2 into 60% of broken wire. So this how to calculate this we already discussed in our stage 6. So you can refer those video. So this 154 kg to be applied for stringing ground wire condition, that is load case 53 and 54. And similar like for f of x, this we need to consider as per the calculated here. So for earth wire it is 510 kg and for conductor it should be 1020. So as only stringing is done in earth wire, we should consider this 510 kg in f of x direction. And this transverse load is more common we are just calculating this as per the deviation. So this is applicable only in deviation cases. So far without deviation the transverse load remain 0. So this is all about the stringing earth wire in both the side as per this case. So here next case 55 and 56 we are doing stringing only in the left hand side of earth wire fixing point, whereas here that weight of the earth wire should be considered for full span or normal condition, and also that longitudinal force remains 0. So the transverse load is applicable only for deviation cases, conductor deviation cases. So this 257, that vertical load which had come from this normal condition. So next is load case 56 we had seen, and 57 we are applying the stringing at the top. So for top means only for that f of z and f of x we need to consider as a broken wire. So let we do it for suspension tower so that we can check that. So for suspension tower, all the longitudinal loads except the broken wire condition remains 0. Only for the broken wire or stringing alone we need to consider. Say for example, you can see here in that definitions which we had discussed in stage 6, only for the broken wire condition we need to consider the conductor and earth wire tension. So for broken wire condition it is 1020. So remaining intact wire it is 0 for longitudinal loads, so it is 6. It is 0 for all the things. Similar like for f of z, that is vertical load, instead of full span we need to consider only the 60% broken wire. So there is a calculation here in 2 into 60% of broken wire span. So this 527. So this summation we did here 587 plus tension insulator, suspension insulator, plus lineman with kid cross arm. So all this value 1881 kg of vertical load and 2272 kg vertical load we need to apply it for normal broken wire and normal conditions. So that was we had done here. So this is broken wire or stringing of top conductor which is having 1881, and 2272 is for normal cases. So this value we had applied here, and transverse load remains same for all the cases because in deviation. So you can see here anyhow we are not going to consider any wind load, but in case of tension in transverse side, due to that deviation we are having both values in conductor and earth wire 195 and 42. So that we are going to apply here, because this is already described here. 100% of the load we need to consider for both normal and broken wire condition. It was stated in class 12.1.3 of IS 802 part 1 section 1. So the same one we are going to apply furthermore, that is in the next case top conductor stringing one side. So in the other side we are applying the intact force which we had calculated, applied like before cases. So in the next cases we are applying this broken wire or stringing in mid conductor on both sides, remaining is intact. And in the next case 63 and 64 we are applying this broken wire or stringing in mid conductor only in one side, that's in left side. Here it is lower or bottom conductor is stringing in both sides, and these two cases are bottom conductor stringing in one side, left side. This is bottom plus mid string in one side, as we had seen in security cases, similar like the cases are. And this one is load 71 and 72 are one side stringing of bottom and top. So this one is mid plus top, remaining are intact. So this is also one side, and this is a final two load combination 75 and 76 under safety loads. So in this, all the three conductors, bottom, middle and top, are string in one side, and the other side it is remain intact. So these are all the cases in suspension tower. Let me also check what the changes in case of tension towers or angle towers. So for tension tower or angle tower, if you refer to that load trees, so here you can see some value in longitudinal direction f of x in even in that intact direction also, which is also higher than that. Why it is? Because it is given in the IS 802 code book. There must be a longitudinal loads we need to consider in the normal condition cases. So that is why it is 3354 kg, and for broken wire condition it is 2236. So if I am telling that it is a broken, so that in that case I need to consider this 2236 in case of without deviation, and with deviation it is 2220, this one, and for normal condition it is 3329. So those we need to consider for tension tower. Similar like this weight also we need to consider as like calculated. So it is a summation of the normal condition, and similar like this 1869 is a summation of broken wire or stringing conditions. So that is what consider here. So this is what all about the load trees. And also, if suppose I am going to consider or I am going to design this as a dead end tower, so let me do this. So what happened to the load trees? Let me see. So here, so for dead end tower, in the case, this stringing case is not applicable for dead end tower. So that's why it is showing not applicable. So we can ignore this load cases if you are doing for dead end tower. So these not applicable cases we should not consider. So for dead end tower we must consider only normal condition under safety. So this 51 and 52 case only applicable in case of dead end tower under safety loads. So remaining things you see, there is no horizontal forces to be considered, longitudinal forces. So here you can see in that slide table, mechanical tension should be considered only in normal condition cases, that is 100% of conductor earth wire at everyday temperature forces. So there is no need of consider any broken wire condition cases or stinging in case of dead end towers. So similar like for security cases also, only two cases are applicable under broken wire condition for security cases, only this one. Earth wire condition alone is applicable for both the cases and one side cases. For broken conductor wire, these cases are not applicable. So in case of dead-end tower, we can conclude that under normal condition we are having two. See, these two cases will applicable for a dead-end tower under reliability load cases, and for security cases only broken ground wire is applicable. That cases is having 4, and for safety cases only normal condition we need to consider. So 2 in reliability, 4 in security, and again 2 in safety cases. So there are 8 cases alone to be considered in case of dead-end tower. But in case of suspension and line tower or tension tower, these 52 cases are applicable. Even for some of the load cases, it's not applicable for suspension tower also. So this is all about the load tree calculation. We will see in another video. Thank you for watching. Look at description for more related video. Subscribe to this channel for more updates. Thank you.